2.5. Solve equations with variables on both sides. I will return to this vocab term in a bit. Concept summary. Steps for solving linear equations. Step 1. Use the distributive property to remove all grouping symbols. So as you can see, the difference between this lesson and the previous lessons is that this equation has two variables on both sides. But the way you solve it is very similar. But before you do anything, you need to first simplify each side of the equation. So the first thing we would do is to remove all symbols. In this case, we have to use the distributive property. So we will first recopy 1 plus 14j on the left-hand side of the equation because there's nothing we can do to that. And then we need to distribute the 2 into the difference of negative 4j minus 13. So that's and then we get negative 8j and negative 26. 2 times negative 13 gives me negative 26. And then we recopy the positive 5. Now, step 2, we need to simplify the expression on each side of the equation. So how do we do this? We have to use the properties of equality to collect the variable terms on one side and the constant terms on the other side. Again, your goal is to isolate the variable. So here I've collected the terms with the variable j. If I move 8j, negative 8j over to the left-hand side, I need to add positive 8j. If I move the constant term positive 1 to the right-hand side, I need to subtract 1. Therefore, I get negative 21 minus 1 on the right-hand side. Now I can combine my like terms on either side of the equation. 14 plus 8 gives me 22j. Negative 21 minus 1 gives me negative 22. Now I can continue to solve for the variable j using the properties of equality, in this case the division property of equality. Now I'm going to divide by 22 on both sides of the equation to get j equal to negative 1. And lastly, it would be wise of you to check your solution by plugging it in to your original equation. So this is your original equation, and I plug negative 1 into j, and I get negative 13 on both sides. So negative 1 is indeed my solution for this equation. So we're going to go ahead and start some practice problems. Part A, solve an equation with variables on both sides. So I'm not going to show all the details. I just want to give you a quick way to get to the solution right away. I'm used to writing the variable on the left-hand side, so I'm going to first collect or combine my like terms with the variable on the left-hand side by subtracting 4x to both sides. So that gives me negative 12x. Now I'm going to collect the constant terms by subtracting negative 7 to both sides of the equation. So negative 17 plus negative 7 gives me negative 24. I can cancel this out, cancel this out. Now x is equal to 2. And if you substitute the 2 into the x back to the original equation, you should get two numbers equal to each other. And for this one, I'm going to first collect the like terms with variables. I'm going to take the inverse of positive 7x. So that makes 2x. And I'm going to add 4 for the constant terms. Negative 16 plus 4 is negative 12. And x equals negative 6. Now here, I'm going to solve an equation with grouping symbols. And you have 1/4 here. Recall from the last lesson that if you have a fraction, you can actually get rid of it by multiplying it by the reciprocal to both sides of the equation. So I can cancel out the 4 on this side of the equation and distribute 4 on the left-hand side of the equation. 36x minus 20 equals 16x plus 60. Okay, so no more fractions. So now I'm gonna start solving. And for this one, I'm going to leave this alone and first deal with my constant terms here. I can divide by 3. And then I can distribute 2 on the right-hand side. And then I can solve. Okay, moving on. Identify the number of solutions of an equation. So for this part, I want to let you know that not all equations have only one solution. You can have, again, one solution, no solution, or all solutions, meaning all real numbers, or in other words, we can call this identity. So this brings us back to the vocab term. An identity is an equation that is true for all values of the variable. That means the solution of an identity is all real numbers. So let me first solve an equation in which it has a solution of all real numbers. So let's see, 6a plus 6, I distributed a 3, now I'm going to distribute a 2. 6a plus 6 is equal to 6a plus 6. So this is an identity. You can either write all solution, all real numbers, or identity. Now let's look at this one. The solution is 0. One solution. So let's look at another one. 9z plus 12. Distribute the 9 on the right hand side. 9z plus 27. I'm gonna put that together. 12 does not equal to 27, so this one is no solution. So these 3 examples illustrate 3 different cases. Word problems. For these word problems, you need to think about how to set up an equation with 2 variables on both sides. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of cars, new cars, sold be twice the number of used cars sold? So we need to first define the variable. How many years is the question? Let t equal the number of years. So here in the last sentence, we have the equation. In how many years will the number of new cars be twice the number of used cars? Okay, so we already have 78 new cars. And it goes at a rate of, increasing at a rate of 6 cars each year, so plus 6t. And how will this be, or when will this be twice the number of used cars? So the number of used cars will be 67 minus 4t because it's decreasing. Okay, so here we have the equation and then we can start solving. Okay, I see that I have a factor of 2. I can divide that to both sides of the equation. Cancel out the 2. 78 divided by 2 is 39. 6 divided by 2 is 3t. And let's see. 3t plus 4t, 7t. 67 subtract 39 is 28. And t will be 4. So write and label your answer clearly. 4 years. Flyball is a relay race for dogs. In each of the 4 legs of the relay, a dog jumps over hurdles, retrieves a ball from a fly box, and runs back over the hurdles. The last leg of a relay is shown below. The collie starts the course 0.3 of a second before the sheepdog. So I'm going to let t be the time for the collie. And the sheepdog started 3 seconds later, so I have to subtract 0.3 of a second. Let t represent the time in seconds it takes the collie to run the last leg. I just did that. Write and solve an equation to find the number of seconds after which the sheepdog would catch up with the collie. So again, we need to use the concept of RT equals D. So for the collie, the distance would be 23.4 t. And they're going to run the same amount of distance. So I could set that equal to 24 times t minus 0.3. And because of this factor, this will tell me when the sheepdog will catch up with the collie. And after solving for t, okay, let's solve for t here. seconds. Part C. Will the sheepdog catch up and pass the collie during the last leg of the relay? Explain using the answers in part A and B. So I have it written for you already. The answer is clearly no, because first of all, it takes 12 seconds for the sheepdog to catch up to the collie, and that's found in part A. And in part B, the collie only takes 4.4 seconds to finish the last leg. So the collie is way faster than the sheepdog, and by the time the collie finishes, the sheepdog is still running and at a much slower rate. And this concludes our lesson.